audience, my name is Diana Popa, and I'm a scientific researcher at Agricultural Research and Development Station Secuieni Neamț. I'm one of the corresponding authors, and I'd like to present you today certain aspects regarding the greenhouse perennial wall rocket crop as influenced by mulching and fertilization practices. Diplotaxis tenuifolia, the perennial wall rocket, is a species belonging to the Brassicaceae family, which regenerates easily after harvesting by cutting the leaves 3-5 cm above the soil surface. The extension of the areas cultivated with perennial rocket in the last 2 decades is due to its fine and succulent leaves that correspond to the consumer's requirements, the leaves of this species being rich in mineral elements and antioxidants. The cosmopolitan distribution of the Diplotaxis tenuifolia species results from its easy adaptability and propagation. In our country, this species is not known in the native specialized literature. In this context, the purpose of this paper is to evaluate the effects of the mulching and fertilization on some physiological and production characteristics for a perennial wall rocket grown in protected spaces. Based on these first results, research perspectives may open to highlight the value of this species and possibly to promote it within the vegetable assortment of our country. Preliminary research on the Diplotaxis tenuifolia species was carried out in 2019 in a polytunnel on an area of 130 square meters from the experimental field of the vegetable growing discipline belonging to University of Agricultural Sciences and Veterinary Medicine, Iași. The experimental protocol set up the establishment of a bifactorial experiment with 3 replications. The first experimental factor was mulching with 3 graduations: non-mulch, mulch with white polyethylene film, and mulch with black polyethylene film, both 60 micrometers thickness, and the second factor was the type of fertilization with 3 graduations: non-fertilized, chemical fertilization, and application of microorganisms. The fertilization treatments were control treatment without the application of fertilizers, chemical fertilization with crystalline, and the third one was a biological fertilization with a microgranulated fertilizer based on microorganisms, mycoseeds MB. Assimilatory pigment content was measured before harvesting with a non-destructive portable chlorophyll content method. At the same time, yield and biometric determinations were performed after harvesting. According to this table, the average leaf production ranged from 17.7 tons per hectare in the case of the non-mulch variant and 23 tons per hectare in the case of the variant mulch with white film. The difference of 5.3 tons per hectare, respectively 29.24%, recorded by the variant mulch with white film, is considered positively significant compared to the non-mulch variant, while the difference of 1.1 tons per hectare, respectively 6.21%, recorded by the version mulch with black film, is insignificant compared to the control variant of the experiment. Regarding the type of fertilization, the chemically fertilized variant registered a yield increase of 5.6 tons per hectare, respectively 32.37%, compared to the non-fertilized variant, this difference being very significant. The variant on which microorganisms were applied registered a significant yield increase compared to the control variant, respectively of 1.9 tons per hectare, which means 10.98%. Regarding the combined influence of the 2 studied factors, mulching and fertilization, the highest yield increases, with very significant differences from the control variant, were registered for the following variants: white low-density polyethylene and chemical fertilization 61.15%, white low-density polyethylene and biological fertilization 52.23%, black low-density polyethylene and chemical fertilization 42.04%, and non-mulch and chemical fertilization 35.03%. The highest yield value, 23 tons per hectare, achieved in the case of mulching with white film, is supported by the highest value of leaf area, 3.27 square meters per square meter, by the highest quantity of dry matter, 421 grams per square meter, as well as the highest average leaf weight, 1.28 grams. These production indicators having significant values compared to the non-mulch variant. At the same time, the yield increase was also influenced by the number of leaves per nest, 126.6 leaves per nest, even though it presented non-significant values compared to the non-mulch variant. In the case of fertilization, the variant to which chemical fertilizers were administered determined the highest production of leaves, being supported by the highest values of leaf area, 3.30 square meters per square meter, of dry matter, 375.6 grams per square meter, the number of leaves per nest, 126.2 leaves per nest, and the average leaf weight, 1.27 grams. These indicators show significant values compared to the control variant. In the case of combination between those two factors, the highest yields obtained by white low-density polyethylene and chemical fertilization, 25.3 tons per hectare, and white low-density polyethylene and biological fertilization, 23.9 tons per hectare variant, are correlated with the highest values of leaf area, 3.51 square meters per square meter, of dry matter, 466.8 grams per square meter, respectively 454.9 grams per square meter, and of the number of leaves per nest, 136.8, respectively 141.7 leaves per nest. These indicators have significant values compared to the control variant. The average leaf weight, although it had significantly higher values for the two variants above compared with the control, was outweighed by the white low-density polyethylene and non-fertilized variant, which presented the highest average leaf weight, 1.36 grams per leaf. As you can see in this figure, the highest content of chlorophyll pigments was identified both in the case of the non-mulch variant and in the chemically fertilized variant. In the case of the combination of the two factors, the highest content of chlorophyll pigments was registered in the non-mulch and chemical fertilization variant, thus generating yields with very significant positive differences compared to the control variant. In the end, I want to mention two things. First of all, following the experiments carried out on the Diplotaxis tenuifolia species, in the autumn harvesting cycle, both the mulching with white film and the chemical fertilization determined good yields results, but the combination of the two factors led to the phenomenon of synergies, generating the highest yields. And the second, in the autumn harvesting cycle, the species behaves well in the conditions of northeastern Romania. Thank you for your attention.